This video will review how to graph transformed trig equations. As you can see, I have f of x is equal to a and then some trig function, parentheses bx plus c plus d. I'm using this notation that will follow the videos that were introduced about how to graph sine equations and cosine equations from my trig class. So I want to make sure I have that same consistency. In your book, in terms of pre-cal, your letters may be a little bit different, but they all are in the same position and they mean the same thing. So the first thing that we need to remember is that we should be able to find the amplitude. We find the amplitude as the absolute value of a, so it's always going to be a positive number. The other thing that we want to find is going to be our sinusoidal axis, and that one is going to be the y is equal to d. So I like to notice where I position them. It could be here. You can also see it over here in the other version of the equation. Other things that we need to find is going to be our starting point. And we find that by letting my parentheses bx plus c equal to 0. You can also find it by letting this parentheses equal to 0. In either case, you're going to find that x is equal to negative c over b. So we're going to use that starting point as well. The biggest issue that we're always going to have is going to be finding the period and the increments so that we can graph it. So first thing I need to remind you is our period naturally is going to be 2 pi, and then we're going to divide that by our b, which is going to be our frequency. This will give you our period. We'll let period be denoted by t. In order to find increments, and this is more so for sine and cosine, as well as my period information, the increments would be the period divided by 4. And we want to make sure that our starting point as well as our increments to have the same denominator. It'll be easier in terms of our graph. If you are talking about tangent and cotangent, then remember that the period and its natural period is pi, and we would divide that by b. And our increments will be the same of t divided by 4. So that hasn't changed. But the biggest thing that does change is how we find the period. Other information that we're going to need in order to finish graphing is going to be what we call a maximum point, or the upper point or high point. So the maximum we find by using d plus the amplitude, and if you want to find the minimum point or the low point, we would find d and subtract the absolute value. So that wraps up all the different information that we need to find. So let's use an example. So let's start off with example number 1. And let's say we have f of x is equal to negative 4 cosine of pi x minus pi minus 2. Remember, we could have also written this as y is equal to negative 2 minus 4 cosine of pi and x minus 1. Remember, I did the distributive property, will give me back to my original parentheses. And so now we're ready to go find all of our information. We can see that our amplitude is going to be equal to 4. Remember, we find that right here. We get the absolute value of that. We're going to find our sinusoidal axis, and that is going to be y is equal to negative 2. We can find it either here or back here in the back. We can find our starting point. That is when we let our parentheses equal to 0. It doesn't matter which set of parentheses. I'm going to use pi x minus pi is equal to 0. I'm going to add pi to both sides, pi x, and then divide by pi, and we find that x is equal to 1. So that's going to be our starting point. We're going to go find our maximum value. Remember, our maximum value will be our sinusoidal axis of -2, and then we add our amplitude of 4. That's going to give us a 2. I'm going to find my minimum. I get my sinusoidal axis of -2, and I subtract my amplitude, which is 4, which is -6. So this information is very helpful because what we need to do is to be able to make sure that our y values will go as low as -6 and as high as 2. The only other thing we haven't found is our period, so let's go do that as well. Our period, remember, is going to be 2 pi over b. In our case, b is pi. So I divide that and I end up with 2. So our period is equal to 2. Our increments means that I divide this by 4. So our little increments are going to be 2 divided by 4, which is equal to 1/2. So I should use those notches to be 1/2. Remember, we want our starting point as well as our increments to have the same denominator. So I'm going to change this to 2 over 2. That's the same thing as 1. So our starting point will be at 2/2. So let me show you how that's going to come around in terms of our graph. So I think I'm going to go by 2's on my y values, because that way I can get -6 down here. And I get my +2 as my maximum, so that's good. For my x values, our starting point is at 1, so that I'm going to put it right here as 1. That's the same thing as 2 over 2. And then our increments are going to be 1 over 2. So I'm going to do 1/2, 2 2's, 3 2's, 4 2's. And you can see that each one of these is going to be my increment. So we are doing cosine. Big thing to remember about cosine, it starts at the maximum, hits the sinusoidal axis, goes below to the minimum, comes back to the sinusoidal axis, and then hits a maximum. So these 5 points are the ones that we're going to use. But remember, we have a negative. That just means that our graph is not going to look like this, but it's going to have our sinusoidal axis, and it's going to start at the bottom, go to the sinusoidal axis, to the maximum, to the sinusoidal axis, and then to the minimum. So it's going to look like that. So our job is to make sure our graph looks like this. So let's get started in terms of our graphing. I go to y is equal to -2. This is like our new x-axis. Our starting point is at 1, so that's right here. So this is like our new origin. So from here, we need to have our point, the first point needs to be down by the amplitude. The amplitude is 4, so I'm going to go down from here till I get to -6. That's our minimum. The next increment is going to be on the sinusoidal axis. The next increment is going to be at the maximum. The next increment is back on my sinusoidal axis. The next increment is going to be at its minimum. So this is what we have so far. So I need to get 2 cycles so I can keep coming this way by increments. Notice I'm just going over 1 notch and then picking at one of my points. We can see the same thing right here. The next one will be at its maximum. And next one here, next one at its minimum. So we definitely have more than 2 cycles here. And we have 1 cycle here and another cycle here. Just to remind you that our period from here to here needs to equal to 2. From here to here, our period is equal to 2. So right here, if we started at 2 over 2, 3 over 2, 4 over 2, 5 over 2, 6 over 2. So from 6 over 2 minus your 2 over 2, you can see that's 4 over 2, which is equal to 2. So this distance is 2. That is our period. And that is how we graph this particular function. Moving on to example number 2. Let's say we want to graph something that has cosecant. One of the things to want to remember that this just means sine. So what we're going to do is pretend that we have the equation of y is equal to -1 plus 2 sine of x. So we're still going to find all the information. We can still find that the amplitude is equal to 2. Remember, that's whatever's in front of our trig function, the absolute value of that. And then we're going to find our sinusoidal axis, and that's going to be right here at y is equal to -1. We're going to find our start point, and our start point is when we let the parentheses, which is x in our case, equal to 0. So we're going to start at x is equal to 0. We're going to go find our max. Our max is going to be our sinusoidal axis plus my amplitude, and that's going to get 1. And our min is when I get my sinusoidal axis and I subtract 2, and I'm going to get -3. The last thing we need to do is find our period. Remember, our period is going to be 2 pi over our frequency, which is whatever number is in front of the x, which is 1, so our period is 2 pi. When we're looking for increments, we're going to get our 2 pi and divide it by 4. We're going to get pi over 2. So what that means is we're going to start at 0. Remember, this is 0 over 2, so that we have the same denominator. So that's going to be where we're going to start. So I'll put that right there. And what we do know is that each of these need to be an increment. I'm going to do pi over 2. And then another pi over 2 is 2 pi over 2. Notice I left them like that. This would be 3 pi over 2. This would be 4 pi over 2. I didn't reduce these fractions. So we're doing our sine graph. So what we do know is sine, because it's positive, our number in front of our trig function is positive, sine starts like this, goes up, comes back down, goes to the valley, and then comes back up to our sinusoidal axis. So we're going to keep this in mind when we are doing our sine graph. So I'm going to do this in a different color, so because it's not the actual graph, it's just a guide, so I'm going to do it in a lighter color. So we're going to start off with on our sinusoidal axis, and at our starting point of 0, so it's going to be here. This is going to be -1. Then it's going to be at its maximum. Our maximum is at 1. At our next increment, we're going to go up to 1. Here's 1. The next one is going to be back at our sinusoidal axis, so I'm right here. Then it's going to go to the minimum, which is at -3. So here's -1, -2, -3. And then back up to our sinusoidal axis. So I'm going to put this dashed. And notice I need 2 cycles, so I'm going to come back over here. I'm going to go 2 units, so 2 units, and then I'm going to be at its minimum. 2, 3. And then 2 more units, and back at the sinusoidal axis. 2, back at the max, and then 2 back on the sinusoidal axis. So again, I'm going to put my dashed line. Now I'm going to start doing the asymptotes for my cosecant. Everywhere it crosses the sinusoidal axis is where I'm going to put my vertical asymptotes. Remember, our sinusoidal axis is y is equal to -1, so everything that crosses at y is equal to -1 is going to be an asymptote. And then finally, we're going to graph our cosecant. Here's a nice dark color for them. We're going to make little U's up and down in between our asymptotes and at the peaks and at the valleys of my guided sine wave. Moving on to example number 3. This time we have a tangent, but we're going to still find the same information. So our same information is going to be to find our amplitude. Our amplitude is going to be 3. It's the number in front of the tangent. The next thing we're going to find is our sinusoidal axis. That's going to be y is equal to 1. It's located right here. Then we're going to go find our starting point. Our starting point is when we let 2x equal to 0, and x is equal to 0. So we're going to start there. We need to go find our max and our min. So max is going to be our sinusoidal axis plus my amplitude, that's going to be 4. And our min is going to be our sinusoidal axis minus 3, so that's going to be a -2. So we know that's going to fit on our graph. And then the last thing I need to do is go find the period. Remember, this is tangent, so I'm going to keep pi there. And then whatever's in front of the x, that's going to be what we're dividing by. So we're going to find that our period is pi over 2. And again, I'm going to get that, pi over 2, and I'm going to divide that by 4. Remember, that's pi over 2 times 1/4, which is pi over 8. I want the starting point, which is 0, to have the same denominator as we had for our increments, so that's the same as 0 over 8. So we're okay, or 0 pi over 8. So we can get started in terms of our graph. So the first thing we need to do is go find asymptotes. So what we're going to do is remember that tangent actually starts right here, where this is our original origin. So I need to go find our starting point. That's going to be our origin there. So that's going to be at 0 and 1. So we know we're going to start at 0, 1. That's going to be our middle point, but that's not our asymptote. We're going to go over one increment, and that's going to give us our high point. And then we're going to go over another increment, and that was going to give us our asymptote. So this is going to be our asymptote. So notice we started at 0, we went to pi over 8. This is going to be 2 pi over 8. Then the next one is going to be a low point, and then it's going to be the midpoint, it's going to be the high point. This is going to be our asymptote. So again, notice it's going to be, so that's 2, 3, 4, 5, 6 pi over 8. And if you think about that, the difference is 4 pi over 8, which is the same thing as pi over 2, which is our period. So we're doing the same thing over here. So I'm going to go 1, 2, 3, 4. That's an asymptote. 1, 2, 3, 4. That's an asymptote. All right, we're ready to graph our function. So we know that our sinusoidal axis is at 1, so that's right here. We know that the next one is going to be our max, is going to be at 4. So I'm going to come over here, 1, 2, 3, 4, and negative 2 on the other side. So we know it looks like this and gets closer that way. So again, I go to the middle, is in the middle. Then to the right, I go to the max, and to the left, I go to the min. And I've done at least two cycles. And that concludes this video.